Right then, so these are the questions for the low-level languages. So as what I've done before is, as soon as I get onto the slide, if you pause it, then you can have a go at it, because I'm going to go straight into giving my answer, then the proper answer. So explain the purpose of an accumulator. So accumulator, that is the... No, it's not the add-in thing, is it? It keeps track of something. So is temporary storage within the ALU, so arithmetic logic unit. It'd probably be good if you do say arithmetic logic unit instead of ALU, but you might get away with just saying ALU. So explain the purpose of an accumulator. So it is temporary storage which holds data being processed, and it deals with the inputs and outputs of the processor. So it holds the data. Okay. State the type of addressing described in each of the following. So add the number 13 to the contents of the accumulator. That is immediate, yeah. And then add the number stored in address 25 to the contents of the accumulator. It's direct. Oh, and the stored address. So immediate is the data, direct is the address. Then describe the use and purpose of an index register. It keeps track of it, doesn't it? It stores a number used to modify the address in the address field of an instruction. Used in index addressing, allows access to a range of memory locations. For example, is used to access an array. So the way you answer this is saying it stores a number used to modify the address in the address field of an instruction. The purpose of it is that it allows... then say after, so of an instruction, it is used in index addressing. It allows access to a range of memory locations. It is used to access data from an array. So that's how I would answer it. State the meaning of direct addressing. Oh, direct... I can't really remember. The instruction gives the address to be used, so so make sure you do it, try and do it for word. Explain why it is not possible to use only direct addressing in semi-language. It only handles the address, maybe? The number of addresses available is limited by the size of the address field. Code is not relocatable. Oh, right. So that's what... so the way I would answer this is saying the number of addresses that are available are limited by the size of the address field, and that the code... I'd say the number of addresses that are available are limited by the size of the address field. That's what I say. I'm not sure if you actually get a mark though, if you just say code is not relocatable. You might get a mark just for saying that, but still, try and get as much information down as you can. Describe relative addressing. Allows a real access address to be calculated from a base address by adding the relative address. Relative address is an offset, can be used for arrays, can be used for branching. So I'll answer it by saying it allows a real address to be calculated by a base address by adding the relative addresses. By adding the relative address, it can be the relative address. By adding the relative address, which is an offset, it can be used for an array and for branching. So that would hopefully get you all the marks, and it includes most of the points. Well, it includes all the points actually. Describe indexed addressing. Trying to think. So index, that is in order. So index addressing. I've completely forgotten. modifies the address given by the add-in number from the index register. So index uses the index register to address, so by adding a number from index register to address in instruction. So way I will answer this, hopefully if I can remember it, it modifies the address given by adding a number from the index register to address in the instruction. One feature of assembly language is flow control. Explain the term flow control. Ooh, I didn't actually cover this, did I? Oh well, I've covered it now. So one feature of assembly language is flow control. Explain the term flow control. The way in which data moves throughout a system. The order in which instructions are executed. The order may be changed by a jump instruction or conditional jump instruction. So one feature is flow control. Explain the term flow control. So say it is the order in which instructions are executed, but the order may be changed by a jump instruction. Describe immediate addressing. Used in assembly language, uses data in address fields as a constant. So it is used in assembly language to it is used in assembly language which uses the data in the address fields as a constant. Explain how and why index registers are used. Index registers are used to keep track of processes that are currently being executed, maybe? So you've got to say, used in index addressing, stores a number used to modify an address, which is given in an instruction, allows efficient access to a range of memory locations, or by incremented the value in the IR, so index register. Used to access an array, so I would try and remember to do this as it is used in index addressing. It stores a number used to modify an address, which is given in an instruction. It allows efficient access to a range of memory locations. So those are the points that I'll try and remember. So describe how a jump instruction is executed. An interrupt would that be a interrupt is sent to skip the data, maybe? By changing the contents of the PC to the address part of the instruction, copy address part of instruction in the CIR to PC, so it changes the contents of the PC. So describe how a jump instruction is executed. It is executed by changing the contents of the PC, and it copies the address part from the CIR to the PC. An assembly language uses mnemonics. Explain the term mnemonics. The data... No, not data part, is it? I'll show you. The instruction such as add in add 12, maybe? That might get more marks, let's see. A code that is easier to remember, used to give the opcode or instruction, for example, add. So, just like you get the mark just for the first bit, then the second mark, yeah. So, explain to mnemonics, a code that is easily remembered. It is used to give the opcode the opcode, for example, add. In the context of assembly language, state the meaning of the term opcode, so operational code, and operand. So opcode, that is the mnemonic part of the instruction. Operand, that is the data part. Opcode, the mnemonic part of the instruction that indicates what it is to do. So make sure you do that correctly. Operand, the data part of the instruction. I got it a bit right. So the third market, is it? Oh no. So the third market must be that indicates what it is to do. That must be the third mark or so. A program in a particular assembly language includes the instructions jump CD, jump to instruction labeled CD, then CD ADN 41, so add 41 to the accumulator. Explain the term opcode and give one example for the information given. The opcode, oh, I've completely opcode, that is the jump, or you could have done the ADN, so yeah. So the mnemonic part of the instruction that indicates what it is to do, and then example would be the JMP, or so the jump, or the ADN. Then state the type of addressing used by the instruction ADN41. Type of addressing? I'm going to guess and say direct. Oh, intermediate, I was completely wrong. State the meaning of the term symbolic addressing and give one example from the information given. Symbolic addressing. I've forgotten. Symbolic addressing. I cannot remember at all. Use of characters to represent the address of a stored location, i.e. the CD. Explain the use of an operand in a assembly language instruction. So explain the use of an operand. Operand is the data part of the instruction. It is manipulated by the opcode. So you've got to say, oh, you didn't even get any marks for that then. So address field in an instruction, it holds the data to be used by the operation given in by the opcode. For example, 12 is the operand within add 12. Describe direct addressing and indirect addressing, making clear the difference between them. Make use of diagrams. Not really sure how you'll do the diagrams, but what I would do is I'll just describe what direct addressing is and describe what indirect addressing is. So direct addressing, and I've completely forgotten what that is. So direct, the simplest, most common method of addressing uses the data in the address field without modification. For example, add 12, use the number stored in address 12 for the instruction. It limits the memory locations that can be addressed. Then direct, that is the address that is indirect, is saying you go here, but then you add this many to it. So uses the address field as a vector or pointer. So go to this place, go to that place, then add this many amount of numbers or so. So uses the address field as a vector or pointer to the address to be used. Used to access library routines. For example, in add 23, if address 23 stores 45, address 45 holds the number to be used, increases the memory locations that can be addressed. So that is 6 marks, so I'm not really sure how you do the diagrams. If you know how to do the diagrams for this, like, you may use diagrams. Not really sure what it means by the diagrams though. Is it meant to be how it would look? Because I'm not really sure how it would look. Anyway guys, that is the end of this, so thanks for watching this video. The next video is on databases, and I'm not exactly sure what part it is. So anyways, thanks for watching this video.